Hello, dear students. You're welcome to Arc Institute. I am Dr. R. K. Saini, and today I am uploading mock test paper 2 for NEET examination. In this paper, we have included 15 most important questions from inorganic chemistry. These questions cover a variety of topics such as periodic table, chemical bonding, coordination chemistry, D and F block element, and some basic concept from P block. As you all know your exam date is very near. So I strongly recommended that you carefully read and solve these questions. By practicing them, you will be able to understand the basic concept of inorganic chemistry more clearly through examples. Right? Now, let's begin. Question first. Question first taken from molecular orbital theory, particularly chemical bonding and the electronic configuration of O2 molecule. As you know, O2 molecule contain total 16 electrons are there, and we know that 16 electron in which no sp mixing is there, and as the energy of 2pz orbital is less, 2pz orbital is less than px and py without sp mixing, and hence total 16 electron are there. Therefore, the example 4, 1s2, 2s anti-bonding. First, sigma bonding 1s2, anti-bonding 1s2, sigma 2s2, sigma star 2s2 anti-bonding, and then sigma 2pz2. If nothing is mentioned, then we consider Z is a internuclear axis. Then pi 2px, pi 2py, and anti-bonding pi 2px1, pi 2py2, and it is the most important phenomena because anti-bonding 2px, anti-bonding 2py, pi orbitals are degenerate, and according to Hund's rule, 1 by 1 with parallel spin, electron enter into first, and as option 4 is correct. Question number next is also taken from chemical bonding. Correct order of carbon oxygen bond length. Bond length depends upon size of atom in which both carbon and oxygen. Then depends bond order. When we know that more bond order, then bond length become stronger, become weaker or very short. In carbon monoxide, triple bond is there between carbon and oxygen, and hence the bond order is 3. Bond order 3 means bond length is very short. In CO2, bond order is 2 between carbon oxygen. Therefore, slightly larger bond length of carbon oxygen in CO2 than CO. Then now consider formate ion HC double bond O negative. It has two resonating structure in which partial double bond present between carbon and oxygen. Therefore, its bond order is 1.5 between carbon oxygen due to resonance, and hence its bond length is greater than CO2. And now last we consider carbonate ion. Carbonate ion, it has three resonating structure. It has three resonating structure, and hence the bond order of carbon oxygen bond is 1.33, is 1.33. Therefore, it is longest bond, and hence option 4th is correct. Smallest bond in carbon monoxide, some larger in CO2, some more larger in formate ion, and longest carbon oxygen bond length in carbonate ion. Question number 3rd. Very important question, and question 3rd taken from D and F block element, and it is the method for the formation of KMnO4 in laboratory. Right, balance reaction in ionic form. First, we write half reaction and find n factor for stoichiometry factor of all. In case of Mn, oxidation state of reactant is 2, and the oxidation state of permanganate ion is +7. Therefore, this equation required 5 electron. And in thiosulfate ion, the oxidation state, see carefully, in thiosulfate ion, the oxidation state of oxygen in peroxide linkage is -1, and to oxygens are there in 1 mole of thiosulfate or peroxythiosulfate ion. And in sulfate ion, the oxidation state of oxygen is -2 because the oxidation state of sulfur is not changed, and hence oxidation state of oxygen is changed, and it reduced from -1 to -2. First, we balance the atom, 2 atoms in 1 mole, therefore 2 atoms in throughout the product, and then balance the charge, added 2 electron. Now equation first multiply by the stoichiometric coefficient or number of electron in equation second, and equation second multiplied by equation number by 5 electron, and then we write simple form of by taking stoichiometric coefficient of reactant and product 2Mn plus 2, and in thiosulfate ion we multiplied 5, therefore S2O8 minus 2, and in product side we write 2MnO4 minus because its oxidation state is +7, and in sulfate we write 10 sulfate ion. Now the medium is an acidic by identify the H plus ion, and hence we added H plus ion to balance the charge. In reactant side the total charge is -6 because +4 Mn plus 2 and 10 charge in peroxythiosulfate ion, therefore total -6 charge, and in product side total 22 -22 charge, therefore we added 16 H plus ion, 16 H plus ion, and hence the stoichiometric coefficient of H plus ion is 16 by balancing the charge, and then for balance the hydrogen we added 8 H plus H2O in reactant side, therefore A means 2, A means 2, E means E is the stoichiometric coefficient of sulfate is 10, and F means stoichiometric coefficient of H plus ion is 60, and hence option third is correct. Question number 4. Question 4 taken from periodic table including D block element also. Question 4. Given some information about the element. The element present in group number 12 and in period number 6 means period number 6, and in group number 12 means it is the mercury. It is the mercury. Period 6. We know that in long form of periodic table total 7th period and 18 groups are there. The element is mercury according to given information. First, it does not show variable oxidation state. It is incorrect statement because mercury show variable oxidation state. It exhibit +1 in mercurous ion and exhibit +2 in mercuric ion. Its mercurous ion exists in dimeric form. Mercuric exists in monomeric form. Therefore, statement first is incorrect. It is transition element. It is also incorrect because the element of group number 12 are not a transition element, because the actual definition of transition element which contain partially filled d orbital either in their ground state or in their any oxidation state. But in case of mercury 5d10 no partially filled d orbital, therefore it is not a transition element. It contains 18 electron in their penultimate cell. It is correct because the outermost cell is 6s and their penultimate cell is 5, and hence 5s2, 5p6 and 5d10 total 18 electron present in their penultimate cell. It is correct. It exists in liquid state. It is also correct. Mercury is natural liquid element in D block, and its ionization enthalpy is greater than their adjacent element. It is very important statement. Its ionization enthalpy. Check this statement. In group number 12, it is mercury. The above element is cadmium and the below element is copernathium. The ionization enthalpy of mercury is greater than cadmium, also greater than copernathium, also greater than gold, and also greater than thallium due to s orbital are more penetrate than np. 6p electron are 4 away from the nucleus than 6s, and hence its ionization enthalpy greater than adjacent. Adjacent means right side element, left side element, up element and down element. And hence this statement is also correct. It means C, D and E. C, D, E and E. Very important question. Including periodic table and basic concept and D block element also, because it is mercury. Therefore, the ionization enthalpy, etc. Question number 6. The electronic configuration of element A. 1s2, 2s2, this. The nature of their oxide. First of all, we identify element A. It contains total 30 electron. It means it is a zinc. Zinc oxide. Nature of zinc oxide. Because it is insoluble in water, white PPT, but it reacts with concentrate acid, strong acid as well as strong base. And hence it is an amphoteric in nature. Question next. Which has highest bond angle? First SF2. In case of sulfur, 6 electrons are there. Therefore, the hybridization state in S is sp3. Therefore, their bond angle is less than 109, nearly 104 degree. In HCF2, the hybridization state at xenon is sp3d, because 3 lone pair are there, and we know that in sp3d hybridization the most common geometry is trigonal bipyramidal, and the lone pair of central atom are occupy equatorial position to minimize the repulsion between them. Therefore, it has linear geometry, linear shape. Therefore, it has linear shape and its bond angle is 180 and hence highest. Similarly, SnCl2 sp2 hybridization bond angle less than 120, and in OF2 hybridization state is also sp3, bond angle is also less than 109 or nearly 103 and hence highest in xenon difluoride. First, for same such type of question, first of all, we predict hybridization state and then shape. If molecule is regular in shape, then their bond angle are according to hybridization state. But if molecule is irregular, means contain bond pair and lone pair both, then we check bond angle according to arrangement of bond pair and lone pair according to Vesper theory. And on the basis of Vesper theory, we find shape of xenon difluoride is linear and its bond angle is 180. It is highest bond angle in given species. Question next. Question 7. Taken from coordination chemistry. Question 7. The species having tetrahedral shape. We know that the given species are in coordination number 4. In case of coordination number 4, if central atom is 4d and 5d element or metal ion, then all ligands behave as a strong field ligand because these orbitals are much diffuse. Therefore, interstatic attraction force between nucleus and ligand is sufficiently high, and hence all ligand acts as a strong field ligand. Therefore, square planar type of DT splitting takes place. Therefore, first and third are square planar. In case of 3D element, the strong field ligand is there, and in coordination number 4, square planar geometry is also there. But in example 4, the nickel is 3D element and ligand is weak. Therefore, tetrahedral splitting takes place, in which 2 orbitals, d orbitals have lower energy and 3 are higher energy. Therefore, 4th is tetrahedral species. Question next. The pair of the compound having metal has highest oxidation state. Very simple. And find oxidation state of element. Mn, in option second, Mn oxidation state of manganese is +7 in permanganate ion and chromium is +6. Magnet in +7 and in chromyl chloride, the oxidation state is chromium +6, and these are the highest oxidation state of manganese and chromium in given species. Which of the following obey EN rule? EN rules means the total number of electron in the outermost shell of central atom equal to the corresponding inert gas, and hence we find EN with help of following formula: atomic number minus oxidation state plus electron gained by the metal atom during the bond formation, or generally 2 into coordination number. In last example, the atomic number of nickel is 28, oxidation state is 0, and coordination number is 4. Therefore, 4 bonds formed by the ligand carbon monoxide, and then total 36 electrons are there. Therefore, the complex obey EN rule or obey Sidgwick EN rule or 18 electron rule also. Question number next. Spin only magnetic moment of this. In this question, we find oxidation state of cobalt. Oxidation state of cobalt is +2 because thiocyanate is -1 and potassium carry +2. Therefore, cobalt is +2. All and with coordination with weak field ligand in coordination number 4, it is tetrahedral complex. Tetrahedral. And we know that in cobalt +2, there are 7 electrons in d orbital. And in tetrahedral field, d orbitals are following type, and in 7 electron it contains 3 unpaired electron, and we find spin only magnetic moment with help of unpaired electron by the using of following formula, and as n equals to 3, therefore spin angular momentum is under root 15. Which of the following are isoelectronic and isostructural? Isoelectronic means equal number of electron, and isostructural means their arrangement according to Vesper theory or hybridization state. So first we check isoelectronic. We know that NO3 and carbonate ion and NO3 nitrate ion both carry 24 electrons are there because carbon contain 6 electron, oxygen contain 8 and -2 charge. Similarly, nitrate ion, oxygen carry 8 electron, and nitrogen carry 7 electron but carry negative charge -1. Therefore, total 32 electrons in both species, and the hybridization state at central atom is sp2, and hence they have similar type of geometry or arrangement. In nitrate ion, or nitrogen also has sp2 hybridization state. Therefore, similar hybridization state, sp2, similar type of shape and equal number of electron, and hence are isoelectronic as well as isostructural. In case of, we consider another example, ClO3 negative and SO3 sulfate ion. SO3 sulfur trioxide. The sulfur trioxide is has sp2 hybridization state at sulfur, but in case of anion of chlorate ion, it carry sp3, means their shape are not identical or similar. How many pp bonds in p4? Phosphorus is the element of nicogen family, second element of nicogen family. Its atomicity is 4. We know that the d orbitals are more diffused, and hence p-pi bond or d-pi bond are not formed in p2. Therefore, it complete their octet by the using of sigma bond. And first, all phosphorus 3 phosphorus make single bond and arrange as a equilateral triangle 60 degree, and one phosphorus present above the plane, and this phosphorus also make a bond with all phosphorus, such type bond, and hence all phosphorus make 3 bond, and hence total 1, 2, 3, 4, 5 and 6 pp bond are there. All bonds are equal because this phosphorus present above the plane, and all phosphorus have sp3 hybridization state, means the molecule is non-planar. All pp bond have equal bond length, and total number of bonds are 6. Next, the structure of XeO3. XeO3 xenon present in group number 18, and it carry one lone pair and bond pair. Therefore, hybridization state is sp3, and their structure or shape is pyramidal like as ammonia, NH3. Question 14. Which of the following arrangement does not represent correctly match. Does not represent correctly match. First, scandium, titanium, magnesium. The number of oxygen state is correct because highest oxygen state of scandium plus 3, titanium plus 4, chromium plus 6 and Mn plus 7. First statement is correct. We identify incorrect statement. First, second statement, paramagnetic behavior. In vanadium plus 2, scandium, titanium and vanadium. Vanadium means 3d3 and 4s2. In vanadium plus 2, there are 3 unpaired electrons according to Hund's rule. 3 unpaired electrons according to Hund's rule. In case of chromium plus 2, 4 unpaired electrons. In Mn plus 2 and Fe plus 3, both have equal unpaired electron. 3d5 means 5 unpaired electron. Therefore, their spin magnetic moment or magnetic behavior is equal. And hence, this statement is also correct. Nickel, cobalt, iron and this ionic size. Yes, it is also correct because we know that when we go from left to right in the series, then the atomic size or ionic size reduce, and hence nickel is smaller than cobalt, some larger and manganese is larger. This is also correct. Cobalt plus 3, stability of aqueous solution. It is incorrect statement because the stability of ions in water depend upon their hydration energy. Depends upon their hydration energy. In coordination number 6 generally, and the hydration energy of cobalt plus 3 is highest because the hydration enthalpy also depends upon charge as well as size. All cations carry equal charge, but cobalt plus 3 is smallest in size. Therefore, its hydration enthalpy is highest and it means it is most stable. Therefore, it is incorrect statement. Question number 15. The use of D block element, mainly particularly catalytic property. Titanium trichloride used in Ziegler-Natta polymerization. However, the actual Ziegler-Natta catalyst is titanium tetrachloride and triethyl aluminium. But during the polymerization reaction, it changed into titanium trichloride, and titanium trichloride is active species in Ziegler-Natta. Therefore, titanium chloride, Ziegler-Natta. PdCl2 used in Walker process for the formation of carbonyl compound, aldehyde and ketone. CuCl2 used as a catalyst in Deacon process, and in Deacon process we make chlorine gas at industrial level, CuCl2, nearly 200 degrees centigrade. Therefore, chlorine gas obtained at industry level by Deacon process, then and hence the catalyst is CuCl2. And vanadium pentoxide used in contact process for the formation of SO3 in contact chamber, and finally we make H2SO4 in contact process. And this is the paper, mock test paper 2nd. Okay.